Hello and welcome to this real resilience guide to the Studer B67 tape recorder. In the next 45 minutes or so we'll be talking about the Studer B67, its predecessor the A67, and its cousin the Revox A700. So let's get straight in. The Studer B67. A little bit about the history, put this on the larger screen for you. It was produced from 1973 to around about 1982, and Studer produced many thousands of the machine. It literally was the cash cow of the company in that period. It was available in two marks, the Mark I and Mark II, but within those marks there were probably 80 plus options. Some were mono, some were high speed, running at 30 IPS. The audio cards might have been in a different place. There were VU meters, some with overbridges, some in flight cases. Many options. And then of course we have to take into account the people who bought them, the users, the professional users mainly, would then modify them for their own use. If we look at the basic outline of the Mark I and the Mark II, we can see here on the left hand side the Mark I and the right hand side the Mark II. The easiest way to tell them between the two is the Mark II has these kind of plastic vertical bumpers between the tension arm and the roller here and here, whereas you see they're missing on the Mark I. There are a couple of other changes which are evident inside the machine, different wiring and architecture, but broadly speaking they are the main things. The other thing to look out for, the eagle-eyed amongst you will notice there's no bolt there, and there is a bolt there holding the cap of the counter roller on. Why they changed it? Well, that's various production changes that happened during the lifetime of its production. As I said, it was modified by users. This is the particular common one. It's the BBC modifications in their own trolley. Notice they, below the transport keys, the play and record and speed control keys, there is no grey panel where the amplifiers would have been. They're in another place in the machine, and I'll talk about that a little bit later. And indeed the BBC trolleys as well came in different setups as well. Some did have VU meters on the front. It depends if they were used in television. In radio they tended not to have any meters on them, but they might have had spigots out on the fronts to hold leader tape for editing purposes. So you might come across many of those worldwide really. The BBC sent them to many of their foreign offices across the globe, and so these machines have found themselves in personal use in homes and small studios across the world as well. An illustration of the number of options again. This is the Mark II manual. We can see along the bottom here machines in cases. This particular one has got a carry handles and a cover that goes over the front. These have no covers, but they've got the carry handles. But notice this is a mono machine with a single VU meter, and this one has got two VU meters. And then at the top we have a row of machines in trolleys. The trolley was the same one as the A80 took, but it had blanking side panels when the B67 was not as wide as the A80. But again, various options. You can see the one on the extreme left appears to have no VU meters and just an overbridge which is designed to hold tapes. The one in the middle has no overbridge at all. The one on the right, an overbridge with VU meters. And then right in the center, a rack where a rack mounts versions of the 67 could be located. And again, you'll see below the transport keys, that's large amount of grey, that's where the amplifier cards are, but again, no VU meters on the top. If we look inside the machine, I mentioned about the BBC trolley. Where are those audio cards? Well, they would be underneath the transport control cards and the capstan control board, which are evident from this photograph. So we've got the transport control PCB here and the spooling motor control speed control PCB here, and then the cards in their own crate. Instead of being in front, effectively sticking out from the screen, they are underneath the machine. And there are two L-shaped brackets here which can be freed up by these bolts, swung out, and then the whole crate can hinge down for access to the rest of the machine. The crate itself does not go for the full depth of the machine. There's two legs at the back, because if you took the machine out of its trolley and put it on a bench surface, it would tip back without these two legs at the back. Other than that, the rest of the machine is standard B67. If we look at a close-up of my 67 here, we've got our A700, which I'll talk about a little bit later on, but we can see a classic B67 here in a Studer trolley with the two, or A80 trolley with the two side blanking panels, audio cards underneath the flap here, which can hinge up, transport keys, the machine itself, and then the overbridge with the VU meters, monitor speaker, and the record controls there. The options it came in can be illustrated by these two blank panels here. Instead of no controls at all, this particular one here has the ready safe controls on it, and for some strange reason two headphone sockets there. I don't know where the headphone amplifier was for them, but you can see channel 1, channel 2 ready and safe switches, and then the two headphone sockets. Taking things a little bit further and illustrating the number of options the machine came in, this is for a TV or film sound layoff machine, mono machine with its single VU meter, and we've got a pilot tone and a synchronizer meter here. So we've got a standard record and save controls with a VU meter this side, and then various controls for the pilot tone and synchronizer signals on this side of the machine. It plugs into the standard umbilical on the back of the B67, but if you plug this into this machine here, I've tried it, it does absolutely nothing. Nothing lights up. We don't even get a meter movement, because clearly there are other pins that are not populated on this machine that this connector would have plugged into to get those extra controls for film audio. If we go back to the machine with its covers off, as I said, we've got their transport and capstan motor control boards here. The bottom crate, or if it was hinged up, the crate underneath the transport control keys, we've got our tape tension control pots here for the supply and the take-up motors. 3 pots for play, fast forward, or in this case rewind, so play for both supply and take-up motors, fast forward and rewind, and then there's the peak tape tension control. More about that in the manual. These silver cards here, they are all the audio cards. There would have been a oscillator board for the bias oscillator, and then a stabilizer card, which was take the additional already smooth DC power from within the machine and stabilize it further to supply the audio crate here. There are some other slots here. You can see some blank panels here, additional boards such as a mono and stereo switching, or even coming back to our synchronizer board, synchronizer panel here, probably synchronizer cards that would have been fitted into the crate there. So that is where you will find all the audio boards and the control boards in the body of the machine. Just give you a close-up of that there. The boards themselves were very well built. They were easily akin to the A80 or the B62, the predecessor to the B67. If you know the B77, you'll understand that the edge cards are not really connectors, they're more just pins. Well, the B67 had very chunky connectors to plug the cards into. All of the trim pots were sealed, unlike the skeleton pots you might find on an A77 or B77 in the consumer sector. Although the components were likely to be the good old fracos and standard resistors that you will, fracco capacitors that you would have found on the A77 or B77, the machine itself was designed for professional use and 24/7 operation. So it's very solidly built, and that extended to the card architecture, both for the transport and the audio cards. If we look inside the back end of a B67, you'll see slap bang in the middle is the capstan motor. Very similar architecture to a B77 or A77. If you own one of those, you'll notice that straight away, albeit it has a mu metal shield around the outside. and also you can see that this is the tacho ring that does the same job as the tacho marks on the bell housing of your B67 or A700. This is the same thing on the body of the motor. It doesn't rotate, but it picks up the tacho pulses off the bell housing as it rotates. We have the pinch roller pull-in solenoid here. This is the counter board that drives the digital counter. It does not have the display on it. That was linked via an umbilical, but this does all of the counting up and down and takes the pulses off the counter roller, which is on the right hand side to the right of the head block. Down here is your transport control boards, and then your your spooling motor or capstan motor control, the speed control board here, and your transport control board here. This grey thing here, this little grey bar, links to this mains cable. You'll actually find there's mains on the this PCB. Must be very careful if you take that PCB out, and must make sure that the machine is depowered, because the power switch is actually connected to or mounted on the transport PCB, and it takes the power from the power supply and then routes it back to the inlet, the mains inlet, and then routes it back to the power supply. So there is mains on that board on some solder tags. Above the capstan motor, we have the power supply. We've got the main selector, the voltage selector, and fuse. We also have a 50 to 60 hertz switching to cope for different mains frequencies across the world, which also links to the myriad of motor run capacitors that are in the machine. There's about 5 motor run capacitors, and I'll talk about those a little bit later. To the left of that, a fuse panel. The Mark 1 version and the A67 didn't have this plastic cover over it. Clearly Studer didn't think that was necessary, but then obviously changed their minds when the B67 came out. So under that panel is all the fuses with their legend here where the transformer is. This is the transformer which converts the mains voltage down to DC. This board here with all of the controls is the DC, or all of the connectors, is the DC distribution. There's 4 DC volts on the machine, 5 volts, 12, plus or minus 12 volts, and 21 volts or around 21 volts, 24 volts to run the solenoids. That is the distribution board that runs it out to, say, the counter board, the audio crate, the transport board, and the spooling motor control board. However, I have done a lot of research into this board because I had a machine that was very difficult to fix, and I had to trace where all of the DC volts went. You will find that the DC is actually looped through, daisy chained through the counter board to the audio crate before it then meets the stabilizer board, which further smooths the DC supplies for the audio cards. So it's not necessarily a distribution board that everything is sprung off here to the various parts of the machine, such as the tension boards, the transport board, the counter board, the audio boards. Some bits are daisy chained together. Mains filter here, which will filter the incoming mains, and then we've got more of these motor run caps here, buried either side here and here. You can't quite see them in the photograph, even if I put it on the larger screen. They are where the Rifa caps live for the subboards for the spooling motors, the take up and supply motors, and again I'll talk about those in just a minute. So there's a lot of wires in there, but the harness itself is nicely loomed in, gives you a lot of space to work, and it's very logically laid out. Indeed, if you have the service manuals, this is a particular one for the Mark II here, and this is for the Mark I. It explains all of the distribution boards in reasonable detail, all the pinouts and all the signals they take, but I have further added my information, and I would suggest you do the same to work out where all of the tracks run to here, so you know which connector they say the 5 volts comes in on and then is distributed out to the board. It will help you no end with fault finding. Just in closing on this slide, this is the rectifiers there, these 4 rectifiers here, which are now getting prone to failure. Not as bad as the later A807, which is well known that the rectifiers failed because they're under spec, but they are now, machines that are 50 years old are starting to fail. and is indeed these big Fracco gold cans are the smoothing caps for the power supply and for each of the regulators. They are 4-pin capacitors. There are only 2 pins are the positive and negative because they're electrolytics, so they're polarized. The other 2 pins are merely for mounting purposes. But I have found replacement 1000 microfarad to 2200 microfarad, depending on which value they are and whether it's a Mark 1 or Mark 2 board, will easily fit in here. And although they've only got 2 pins, you can still orientate them so they go into the original PCB. So that's where your main regulator board is here before it jumps off to the distribution board. Incidentally, if your machine is in a trolley like this, it's very common that you will not find this back panel on the machine. For some bizarre reason, Studer didn't seem to fit a back panel on trolley mounted machines. I don't know why. If you get a BBC machine in a trolley, it's very likely it will have a back panel on it because the BBC insisted. I know that for being an ex-BBC person, and the safety, how seriously they took safety and electrical safety both in the studio and for us maintenance engineers. But for some bizarre reason, when they're in these A80 type trolleys, I've never found one with a back panel on it. Yes, you'll get them when they're in carry cases, when they're standing vertically and with just side cheeks on them, but not when they're in a trolley. Let's look at the infamous Rifa capacitors. Rough rule of thumb is there's probably about, we think there's about 9 to 11 Rifa caps dotted around the machine. Certainly where 6 of them are, there's 2 boards next to the spooling motors, the supply and take up. They have 3 Rifa caps on each. This is a good example. My B67 here, ready to demonstrate to you for this video, but unfortunately it blew a Rifa cap and now is stuck in fast forward. And it's these little devices here. As you can see, that one's gone bang quite spectacularly, and I have just taken that number, 6 of them, out of a B67 I'd worked on. They were all on these boards here, and all had started to bulge or had blown. These subboards, as well as holding those 3 Rifa caps, very prone to going, and you'll see that when you power the machine up, it's stuck in fast forward or rewind depending on what board is being affected. There is also an MJ411 power transistor which runs off the red, white and green wires, and that goes to a heatsink on the back of the machine. Now the case of that MJ411 transistor is positive. And that's why, firstly, when it's bolted to the heatsink, which is at 0 volts at ground, it has to be bolted on with an insulator and with 2, and the bolts have to have insulators around them, because if you don't, you're effectively tying the 125 volts or so that's on the case of that MJ411 to deck, and the machine doesn't like it. But also, on a safety point of view, be aware that if you take the rear cover off, or the back cover exposing these 3 power transistors, because there's one for each motor in the machine, the spooling motors and the capstan motor, one for each machine, they have effectively got quite high volts on them. So just be aware of that fact, especially if you find they've failed. Make sure the machine is depower first before you start unbolting those power transistors. But the board itself, it runs through to, it has about 10 connections on it. The manual will tell them all the color codes, because you've got the 125 volts coming in, that's the black wires. You've got the MJ411 transistor. You've also got the motor itself, which has got 3 wires to it. And then you've got the control voltages coming in on the white wires. You can take a photograph of it, but you'll find that the manuals themselves, they will list all of the color codes that you need to plug up to these connectors. Just make sure you get the orientation of the board round so you know what you're working on. They are held on to that self-same heatsink that takes the MJ411 transistor by a single bolt. and it's a little bit of a fiddle to get them out. It comes out quite easily, but sometimes you can drop the bolt, and also just pulling all of these wires off, you need a pair of pliers, and you can end up with lacerated fingers as you're trying to get them out. But it's something that has to be done to change the Rifa caps. Those two boards, one either side of the machine next to the spooling motors, have got to come out to be replaced. Top center of this image are two silver cans. They are the motor run capacitors. If we just drop back a slide to the previous slide here, top left, you'll see there's three motor run caps there, and then there's two more on the right hand side of the machine. All machines that have AC spooling motors need the motor run cap in them, so we're going to be having, if you're a B67 or an A700 owner, you'll be familiar with those three motor run caps that live on the left hand side of the machine below the supply motor. The B67 has 5 motor run caps, and it's all to do with this switch here, the 50 and 60 hertz for international mains switching. When you switch it across, and I'm sorry I can't quite remember, but the manual explains it all, when you switch it from one frequency to another, I think it's to 60 hertz, it switches in a smaller motor run cap. The other one's buried just on this side of the machine. They're wired by this rather, though the machine is nicely built and nicely loomed in, these wires are rather, apologies for installation, they're both taut and poorly installed. They really do spoil the look of the machine. But they are wired by these white and grey wires to the switch and to the motor run caps. When you switch the switch over, it puts a 1.5 microfarad motor run cap in parallel with the existing motor run cap that supplies the motor for the supply motors and take-up motor, switches them in parallel and changes the capacitance. Sometimes I've had with customers to make things simple, remove this. We've removed the smaller capacitor, because if the machine's only being used in, say, UK mains frequency, we don't need to worry about switching it. So perhaps you might want to consider that where you might be using your machine. The other issue to take into account is that modern motor run capacitors tend to be rather fatter in diameter now, but shorter in length. So although they will fit into the machine top to bottom, plenty of space, they won't go near the counterboard at all. There are 3 mounting holes in the rear deck plate that holds the rear heatsink, that holds those MJ411 transistors to cool those. Those 3 stud mount motor run capacitors fit through 3 cast holes in that heatsink, and modern motor run caps, you will not get 3 close together. You'll get 2 in, but you will not get that third one in. And I've spoken to my colleagues, and they haven't been able to find a motor run cap of a smaller diameter equivalent to the existing Studer motor run caps that were fitted originally in the machine. They haven't been able to find ones of that smaller diameter. So as a result, to fit them in, we have had to make things like brackets which extend the motor run caps down to give us some more space, bolt it into the original holes, extend it down and put the motor run cap down there. Or, as I said, you might want to take the option of removing those smaller ones, and you'll always fit 2 of the new size into the existing holes. There's enough space for them, just not to be able to get 3 in. And it's the same on the other side as well. But overall, they're a nicely built machine. I'm very, very pleased with this machine until the Rifa caps went bang on it. And also we have our A700 just rolling around in the background there, which I will talk about now. So, predecessors and variants: the Studer A67 and the Revox A700. This is what a Studer A67 looks like. Very similar to the B67 on first viewing. We've got our grey panel where the audio cards live. We've got our transport keys, head block in the centre, and nice silver deck plate. But notice the first change is that the deck plate surround is grey plastic. This is the one that's taken straight off the A700, which is more of a consumer machine, and they fitted this grey plastic surround. The 67 I have here has the B67 I have here has a metal deck head blocks around, much more robust. The other thing you'll notice is bottom right, no digital counter. It's a mechanical counter that's driven off the counter roller here. There's a drive belt which drives the mechanical counter here. Still has the speed controls here, still has the transport controls here, and it also has the switches on here to power the machine. Incidentally, there's no light in that power switch. It's just a dumb switch, but that does have that mains voltage on the PCB that connects, or all these switches are mounted on. There's a rewind button. You hold that down. As long as you hold it down, the machine goes into rewind and you can hear the audio chatter, which is the same as the B67. And then they have various other pause control and other motor drive controls as well. But that is the major changes. The other things that's quite subtle is that the tension rollers here and here, although they look the same as the B67, they're actually the same ones that appear to be used on the A700, and they're not as high, they're not as chunky looking as the one that was used on the B67. Don't know why, but that's just the major changes you'll see on the A67. Physically, external dimensions is exactly the same size as the B67. This is what one looks like inside. As you can see, fairly similar to a B67. We've got our mains filter at top right, and we can see the Rifa caps as well, which I spoke about, and right at the top of the image the 50-60 Hz switch next to the voltage selector and main fuse. The fuse bank left hand side, just like the B67 Mark I, had no plastic cover on it, but it's a row of fuses to protect all the distribution. And then there is a power supply just to the left of that, the regulator boards I should say, just to the left of that, between it and the take-up motor and those three motor run caps. Got a better illustration of where those Rifa boards live. They live up here and here, fairly buried in the 67, but B67 machine, but in the A67 they seem to be a little bit more accessible. And the other thing to note is that's where the counter's driven off from. The counter on the right hand side of the head block. In the B67 it uses a tacho read head to get pulses to drive the digital counter, but in the A67 and indeed the A700 it's a drive belt that comes off that roller to drive the mechanical counter. The mains distribution board here is a lot simpler. It's just although it's the same architecture, same principle, a lot of connectors coming in, bringing DC power in and other signals to distribute it out to other boards, and is nowhere near as complicated as the B67. At the bottom here we've got our spooler motor control board and capstan motor control board, and then transport control board here for play, record, rewind, and the motor off functions. They seem to be smaller board, or is a smaller board than the B67. Different PCB layouts, and there's pots in different places. There's about 2 or 3 variants of these particular boards across the 67 A700 range. Slap bang in the center, we've got the lift solenoids for the tape to lift the tape off the heads when the machine's in rewind or fast forward, and then they're same place as the B67, the pinch roller lift solenoid. Let's move on to the A700. At first glance, you can see the cues that the A700, which came just before the B67, as far as we can tell, the cues that it gave the B67, same rollers either side of the head block, same tension arms, and the same transport key layout. When it was introduced in around late 1972 and 1973, it was hailed as the most advanced reel-to-reel tape machine for the consumer market, and indeed many found their way into semi-professional professional studios as well, because it had active tape tension where previously many machines of its class didn't, and it had many other professional features. Full logic control, you could go straight from play to rewind, rewind straight back to play. It was expensive. It was 2.5 times the price of an A77, so you had to have a considered budget, considered outlay before you bought one. The major difference, of course, is all of the controls below the transport keys. As you can see, lots of fader sliders, rotary knobs, and 2 lovely large VU meters, which is actually one unit. The meters move kind of up and down in one part. So the problem is, if one meter fails, the unit, the whole VU meter unit has failed, and they are very, very hard to get hold of nowadays. My experience is that it's bits that people touch are likely to fail. So we find that the faders can snap, the fader arms. Remember, we're talking about a machine that's heading for 55 years old now. Those fader posts where the knobs are mounted on can break, and also the rotary knobs can drop off and get lost. The mechanical counter, it should say, exactly the same as the A67, as is the plastic surround, although the head block cover is of a different design. The deck plate is metal, although it's a dark grey, it is actually metal, it is not plastic looking. The audio cards themselves are not held underneath the audio crate here, but in a small box they're over this side of the machine near the supply motor. If you know your B77 machines, where the audio cards are mounted on a lot of small pins rather than an edge connector, but they also have those skeleton pots for adjustment, you'll know that you'll be at home really with the A700. They're mounted in a small box, probably about 15 centimeters square, and all the cards vertically for audio, record, replay, bias, those kind of things are all mounted in this small crate which sits there. There's not then the discrete cards in the bottom of the machine underneath a hinged deck plate, which is what you'll find with the B67. The build quality is good. It is very good. I mean, if we look at the inside of the machine, you can tell, you know, it's been a considered construction, these 67s and the A700, but it is in no way in the league of the B67. Again, they kind of upped their game in the quality build, because they knew the 67 was going to be used, or the B67 was going to be used in a studio environment for perhaps 24 hours a day, 7 days a week, and had to be built as such. So that's our A700. If we just pop it onto the camera there, as you can see, this one's rolling away quite happily. Notice that the lights here on the machine are illuminated. You can see the machine's running at 3 3/4 at the moment, and the play lights on. All of the buttons here have lights on them, with the exception of the play button. That's just a dumb switch. But one thing you must realize, especially if you are looking to buy one, as we can see here on this image here, the 15 IPS light is on. When you change the speeds, make sure that that light comes on solidly. If it doesn't, it could be something simple as a blown bulb. There are filament lamps in those switches and they might have blown. But I've also found that, especially if a machine, be it B67, A67 or A700, if it's been used for editing, you can get tape confetti, tape off cuts that can drop down in the switches and can short out the contacts, because it's effectively contacts of the switch go on PCB pads, and the tape confetti can get down there, and also the switches can start to fail. Although they're bolted to the PCB, they're plastic, they're 50 years old, and they're starting to move out, especially as, you know, the buttons are being pressed probably thousands of times over its life. You might find, and this is a serious, when you get a serious issue to consider, the lights will come on solidly when the machine has reached lock, and this is regardless of the 3 machines we're talking about. When the machine has reached its correct lock, say 15 IPS, 7.5 or 3 3/4, that light will come on solidly. Whilst it's doing that, you might find that it's flashing just to get up to speed, and then it will go solid. If you find, especially at the lower speeds, 3 3/4 and 7.5, it's trying, the lights continuing to flash, maybe those go solid, and then drops out again, it could well be something to do with the tape transport control board. Probably not the capstan motor. My experience is the machine will run quite happily at 15 IPS, but it could either be an issue with the capstan motor control board, the small board that's underneath these three switches here, underneath this board here, and you'll find that regardless of the machines that we're looking at, of the three machines we're looking at, or it could be the tacho head on the capstan motor. I found sometimes if the motor is not, if the tacho head has moved slightly, it's not the tacho pulses coming off the bell housing are not sufficient to induce themselves into the tacho head at slower speeds. It seems to be fine at 15 IPS, but at the slower speeds it doesn't tend to induce enough level, and the machine has trouble finding lock. So it could be one of those two areas. If it's the capstan motor control board, it won't be an IC failure. There's some hard to find IC failure ICs on those machines, but if it is that, you can source those ICs. They're very hard to find, very rare, they're obsolete, but there is a source in Australia, albeit they're very expensive. And there's also a guy in New Zealand who's also doing code and has made it freely available on the Tape Heads forum, which you can, with an EEPROM programmer, program your own device to remake these devices. But the good news is, if the capstan's getting up to speed at 15, it's not these ICs that have failed. It's likely to be caps on the board. Just globally recap that board and replacing all of the small tantalum capacitors as well. But or it could be your tacho head not quite getting sufficient level. One of those two areas. So, common issues. I've just mentioned about a capstan speed control board, Rifas and motor run caps, the myriad of motor run caps and Rifas we're finding there. Find one blown, replace all of the Rifas, and the motor run caps is the same thing, especially if the goo's starting to leak out of them. Incidentally, there is talk that the motor run caps themselves, the big cans, might have PCB inside them, which is not nice stuff to get on your skin. It is toxic, so do wear gloves if you're seeing all of the goo starting to come out of those motor run caps. And I've also mentioned the PSU regulators. I'm finding that it's not a go-to, but I have found a fault on them, unlike the A807, which came out 15 years after the B67, where effectively the regulators were all under spec for the machine, and it's common if a dead A807, you replace all of the regulators. Unlike the B67, they have lasted quite well, but we're talking about a machine that's heading 60 years old now, and I found they are starting to fail as well. And again, if it's the capacitor that goes, it will take the regulator with it. So that's something to consider. So that is really a guide to the Studer B67 and its predecessor, the A67, and its cousin, the Revox A700. I hope you found that informative. I will leave my details on the screen here. Please like and subscribe in the comments section below, and I will see you in the next video from Real Resilience. Thank you.